In the previous lesson, we learned how to prove that two triangles are similar or two triangles are congruent. And we also added the fact that if two triangles are similar, then corresponding sides are proportional. Now that last little point is actually very useful because if you know that the corresponding sides are proportional, you can actually solve for side lengths if you have a pair of triangles which are similar. So you know what, let's just jump into the first question. So we have these measurements here. We want to find the width of this pond. Okay, so let's add some labels here. Triangle A, B, C, D, E. Okay, so the first thing I have to add is that we cannot assume that the two triangles are congruent. Okay, you cannot assume that the triangle is congruent. Or sorry, you can't assume the triangles are similar, nor can you assume that the triangles are congruent. So if you want to say that the two triangles are congruent, you have to show why you believe that is the case, or show how you know they're similar. So we have the different ways that we talked about in the last lesson, like side angle side similarity, side 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 similarity, angle angle similarity, and then you have your the ones for congruence. But anyways, I'm going to prove that these two triangles are similar. So how do I know that? So angle CAB is congruent to angle CED. Now how do I know that? That's given to me, right? If you look at the diagram, it's given, look, this is a right angle, this is a right angle. They told me they're the same. Now, I also know, okay, I also know that angle ACB is congruent to angle DCE. Now how do I know that? Well, that's a grade 9 fact, right? So these two angles, let's draw them. These two angles are also congruent. It's the opposite angle theorem. So in grade 9 you might have wrote OAT, O-A-T in capitals, or your acronym, but I'm just going to write it all out. Opposite angle theorem, okay? So now that I've written this, now we can say that triangle ABC is similar to triangle, let's see, so ABC, so let's say DEC. DEC, let's just make sure, because how you organize these letters make a big difference. So A, B, D, E, B, C is the hypotenuse, and sorry, BC is the hypotenuse, EC, BC is the hypotenuse, D, see, this is not good. This is not work. It should be EDC. Oh, good thing we checked. Triangle EDC. Let's verify it after. So AB, ED, and then BC, DC. Perfect. Okay. So now that we've said that they're similar, you should really provide a reason how you know they're similar. And the fact is angle, angle, similar. That's the condition. Angle, angle, similar. Now that I know that they are similar, triangle ABC is similar to triangle EDC, now I can use that fact that must be true. The corresponding sides must be proportional. Okay, so what's the corresponding side? AC, EC. AC, so therefore 7/3 is equal to ED, which is what we really want, the pond, over AB, which is 4. So ED is equal to 7 times 4 is 28, 28/3. Therefore, the width of the pond is 28/3 meters. Bam, there we go. Okay, so the big idea though, really don't want this to slip away from you, is the fact that you cannot assume triangles are similar. Okay, just because I show you two triangles, you can't just say, oh, they're similar. Okay. Oh, by the way, you could have also shown that angle B angle ABC is congruent to angle CTE using the Z pattern, because these two these two line segments are parallel. Anyways, that's another way of going about to show that the two triangles are similar. All right, so we have once again two triangles here. We have triangle ABC and triangle ADE. So I am going to say, well, like I say, I'm going to write that angle ACB is congruent to angle AED. Now, how do I know that? Well, it was given to me. They're both right angles. And now I'm going to write angle BAC is congruent to angle DAE, and that angle is common. It's shared between the two triangles, so they must be the same. Okay, so guess what? Triangle ABC is similar to triangle ADE. How do I know? Once again, angle similarity. Okay, so please do not assume they're similar. You have to show how you know they're similar. Now, because they're similar, then corresponding sides are proportional. Now we can use that fact. Oh, we forgot to say that Alex here, he's 4 meters from point A, 18 meters from the base of the building. So I'm going to say this is 18 here, and this is 4 here, and this is 1.7 here. These are on meters. And you want to find the height of the building, which is ED. Okay, so corresponding sides are proportional, so you get ED over 1.7. Okay, ED over 1.7 is equal to, now be careful, not 18. It should be, because 18 is not the length of the side, right? It's EA, the whole length of that side is 22. 22 over 4. So ED, let's see, 22 over 4 times 1.7, looking at 9.35. Therefore, the height of the building is 9.35 meters. Okay, let's keep going. We have another beautiful similar. This one, to prove that, first of all, let's add some labels to the vertices here. A, B, C, D, E. So this one, to be honest with you, now it's getting a little boring because this diagram is very much the same as the one in example 2. But you know what? It's good practice. We have to really emphasize that we need to show they're similar. You can't just assume that. So angle ABC is equal to angle ADE that is given to us, and we're going to say angle BAC is equal to angle DAE because that is common between the two triangles. So then we can say triangle BAC is similar to triangle DAE. And the rationale, the condition, is because of angle similarity. Now that I know, I can use the fact that the corresponding sides are proportional. By the way, I want to find the width of the river, so let's call this x. Okay, the width of the river is x. So, let's do this. This is the small one. This is the big one. Okay, so we're going to do 6 plus 9 is 15. And so AB is 15 plus x. 15 plus x, or I say x plus 15, over the whole thing, which is 15 plus x plus 28, right? So 15 plus 28 is 43. 43. Let's write it. Let's write it nicely. X plus 15 instead of 15 plus x. Okay. And this is x plus 43. And that is equal to 7 over 15. Here. So multiply both sides by the lowest common denominator, which in this case is 15 times all of x plus 43. So we get this. And then you basically just expand and simplify. Oh, sorry, expand and solve for x. So 301. Let me just punch these in the calc, just make sure. Okay, so if you do the math, you will get 9.5. So therefore, the width of the river is 9.5 meters. The big idea though is really show that the two triangles are similar, and then once you've shown that, so you might be using side 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 or angle angle or side angle side similarity. Once you've shown that the triangles are similar, then you can use the fact that the sides are proportional. But it's really one step after another. First you show they're similar, then you can use the fact that the corresponding sides are proportional. You cannot jump to this step, because then you'd be assuming that the two triangles are similar, but nowhere in the question did I say. So in the homework, I believe there's some question that says the two triangles are similar. If that's the case, beautiful. I don't have to prove anything because they told me outright. But if I did not add that fact, then you really have to show that the two triangles are similar.